Good evening, everyone. So I'm sharing my screen. Okay, so our today's lab session is based on CNN classification. In day 6 folder, the drive that is shared with you in that day 6 folder inside lab session, you can see the data set is already present over there. So you have a zip file named as yogapose.zip. So we'll be building a model for classification using CNN. So here, let me go to my drive. Inside that, as in previous labs also, we have told you that we have to open our Google Collaboratory. So right click on the path where you want to create your Python notebook file. So I have my path inside my lab 24 June in my drive. There I go to more option and then open Google Collaboratory. So a new blank notebook file would get opened. So first of all, let me tell you what today we are going to do. We have a data set named as yoga pose. So it contains 6 different classes named as down dog, goddess, plank, side plank, tree, and warrior. So it contains different types of postures that are done in yoga. I've taken this data set because recently we have celebrated our International Yoga Day. So we need to classify these images. We are going to classify these images using a CNN model. So initially, what we are going to do is that we will first of all unzip the folder. Then we will split it, and then we will see the image what is present over there. Then we'll build the model, compile it, and then train it. And then we will see what the prediction results. So with this game, let us begin with today's lab. So as you know, if someone of you does not know how to connect to your Google Drive, then go to this left side panel, this files named as files. Click this, and then you will get a Google Collaboratory connection thing here. You can click this mount drive. So we will have to mount our drive to this file, connect to Google Drive. Okay, so it is mounting Google Drive. So here we will see one more pop-up where it will ask me where which drive I want to link it to. So click on that particular thing. Here it has not asked me, so it's already connected. So in this drive, you must be getting this folder drive. Here, go to the path where you have put your data set. So you must have downloaded this data set, this zip file, and you must have copied it somewhere in your folder. Okay. So let me keep it. So let me keep this thing. So I have uploaded the data set. Now what we need to do is we have to unzip it. So first of all, let me go to that particular path where this is present. So inside my lab 24 June, this data set is present. So what I'll have to do is I would write import zip file, import zip file, and then with zip file dot capital Z and capital F for file. And then I will have to provide the particular path that I want to unzip. Copy this and paste it. Then it is in form of as zip. And we have to extract everything. So we will provide zip dot extract zip dot extract all, and then where we want to extract this thing. So I will extract it in this path. Run this cell. Let me increase the font size. Okay. So till here, any problem? If we refresh it, we can see that it is unzipped with the name of upload. Okay. So can you tell in chat box that till here you have any issue with uh, like mounting the drive or extracting? If you have problem with extracting, I have provided you the extracted files as well. If till here things are done, then please write it on chat box. Okay, I will repeat whatever we have done till now. So right now, what we have done is that we have been to this left panel, this icon. We have clicked this, then we have mounted our drive. For that, we have to click to this mount drive. This would be showing you mount drive. I have currently mounted, so it is telling me unmount the drive, but to you it will show mount drive. So click this icon, then you will get into this drive option. The the drive that you have mounted, that it's all of its folders would be shown over here. So you have to click this thing and go to that particular folder where you have kept your data set and your files. So that is all that we have done till now. Let me now what we have to do after that, we have only unzipped the file till here. For that, you have to import zip file, and then with zip file.zip file, we have provided the path, and then we have run this command. That is all that we have done till now. You can't see the drive. See, if you can't see the drive, please reconnect it from here, manage session, go to manage session and delete this thing, terminate this session, and then again reconnect it. Okay, so it will ask you again to mount the drive. Okay, so that can help you out. So Vislakshi, I think now you, okay, then you would be able to do this. So if someone is doing and they are left behind, then I can wait for a while. If you are not till here. Tamanna, link is already shared in above chat box. We have shared this link and daily we used to share it with you. Drive link is already shared. I am again sharing it. Okay, so Komal, are you able to do? Um, I think where you have the Python notebook that which you have opened, that is you have put that in another drive and you are trying to mount it on another one. That must be the issue, Vislakshi. That I think that is the problem. Okay, so should I go ahead? Komal and Vislakshi, can you tell me that are you able to do this? Okay, okay, I'm waiting for a while. Tamanna, everything is present in this drive. In lab 6, you can see there this data set is already present. Okay, I'm showing you here day 6 in lab, inside lab. This is already present. Okay, Tamanna, I hope now you can find the data set. What can I show you once? This is the drive that is shared with you. I'm showing you the path from where you can get the data set. Okay. Uh, you have to go to course content, day 6, and then to lab. Okay, so let us now begin with the next thing. So what we require during our training, during building our model is 3 things: training, validation, and test folders. For that, what we are going to do is that we are having a full collection of those images. Inside that, there are 6 different classes present. So what we require to split all these classes, these 6 classes, into test, train, and validation set. For that, we have already a built-in library. And for that, we will what we will do is pip install split folder folders. Sorry. So here we will have to provide input folder that we need to split. Uh, and the destination one. destination folder, where these splitted images would be divided into three different sets: training, testing, and validation set. So for that, we'll go to this thing, copy this path, and name it as split. So this is the input and output folders of splitted images. So here, input, what we are going to do is import split folders, and then provide the ratio on which we want to split these total images. Split folders dot ratio, and provide the input path, input folder, and output folder. Now we don't require this, so we will close it. Input folder and the output folder. Output as output folder, and then provide a random seed value, that is random value that would initialize that randomness in the splitting of data set. So the ratio that I am specifying is 80 is to 10 is to 10%. So ratio would be 0.8 and 0.1 and 0.1. So 80% would go into the training set, 10% to validation, 10% to testing. Okay, so all good. So it is copying all these files, and here we will be having these splitted images. So overall we have 725 files. So we can see that over here one split folder is now made, and it is having three different folders: training, validation, and inside that all these categories are present on which classification is to be performed. Okay, then all good till here. So are you able to do till here? Okay, can you please reply on the chat box if you people are able to understand and do things? Okay, then let us move ahead, and now what we need to do is, let us see one of the images. So let us see one of any of the image, what it contains. So for that, we will be plotting the image. For that, we require import matplotlib.pyplot as PLT. We are aliasing it as PLT, and then we will be storing this image to img. img equals to PLT dot imread for reading the image, and then we will provide the path. Okay, so copy this path and paste it over here. Then what we will do is we will show this image plt dot show. Inside that we will provide img. So let's display it what it has. So it is a posture of a yoga. It is of type tree. So this we only wanted to see that what is present over here in this particular image. So you can write it till here. If someone is writing, then please do it with us. Go little up this. Okay, so you can print any of the class, any of the image, and see what is present in that folder. Then let us see what values are present in the what the unique values of pixels are present in this image. For that, import. This is the mathematical library NumPy as NP. Again, we are aliasing it as NP. And then we will see the values of each pixel. What unique values are there? Unique np.unique img. Okay, so these many images, these many pixel values are present in this particular image. You can see, use this command. So let us now start with building up of model. All good till here? Are you able to do till here? Komal and Akshita, are you all able to do it? Okay. Okay, Mahadevi is doing. So I'm waiting for 1 minute so that if someone is okay, few people are doing right now. So you all, I'm showing you the code so that you can do it with us. Okay, till here. Import. I think you would have written wrong spelling of split folders. Maybe due to that, you must be having error. First import, which first import? Zip file. I think you have written something wrong over here. Please check the spelling of this zip file and this particular zip file and all these commands. This is what the first cell is, Shivani. This is the first cell. Okay, so should we move ahead? If you have the last report. Yes, don't worry about the code and videos. I'll be providing my Python notebook file. Okay, with every instruction I'll be giving you. Okay. Mm, So if you all have done, should we move ahead? Malika Shri Mahadevi. Okay. Uh, so let us now start with our model building thing. For that, we require certain libraries. So for that, we will be using model. First of all, let us import. Let us first of all import. Someone has raised hand. Malika Shri, what is the issue? Can you write it on chat box? Okay, extract all and above path. What is the difference? See, there is no difference. What extract all? I have provided the path where we want to extract the file. Okay, and the above path is the file that we want to extract. See, it is upload.zip. This is the particular file that we want to extract, and this is the particular path where we want to extract. Okay, that is the difference.
Like,
Fine.
ma'am, am I audible?
Yes, you are audible.
Yeah, ma'am, I just wanted to ask that the file yoga post.zip, wherever like I have it in my drive, I copy the path and paste it in extract all. And in zip file, which path has to be pasted?
In zip file, you have to paste that dot zip folder. Okay, path of
Okay,
that
ma'am.
dot zip, and this is the path where you want to extract it. Okay.
So,
See,
like,
let me show you. Let me show you over here. Um, so this is my upload.zip. So this path I have given it in first zip file dot zip file. Okay. Then in zip.extract all, I have given this path. So here I have got extracted folder with the name of upload. Now, is that clear?
okay, ma'am. So the folder in which we want to
You can
extract, we
give,
have to provide that.
yeah, that is all that you need to do. It can be anything, okay?
Okay, ma'am.
That is up to you, okay? Mm, So we were building the model. Import TensorFlow as PF. Then we will take import TensorFlow as Keras. So TensorFlow is its parent. So from that we would be importing Keras. So sorry, from TensorFlow import Keras, and from this Keras we'll be importing layers, different type of layers that we would be building. TensorFlow Keras import layers. We'll be using this and okay. Then we'll build a sequential model. For that, let us write terrace dot sequential, and in brackets we'll be having different layers. So first of all, let us build a con 2D. The things that you have learned in your theory session, based on that, we'll be using various types of layers. And con 2D, here we'll be providing the filter size, number of filters that we want to use, its kernel size, and what type of padding we want to use, stride. These all things are to be specified in these brackets. So filters is equal to, here we are taking 64 filters. In various examples in theory, you have seen like sometimes you have taken 210 filters. So this is where we specify the number of filters that we want to use. Filters is equal to 64. Then we have kernel underscore size. Here we specify the, sorry, I've written it wrong. Kernel size is equal to 3 by 3. Anything you can take, like 3 by 3, 5 by 5. This is up to you, which kernel size. We have practiced 3 by 3 kernel. So I'm using here 3 by 3, and then specify the padding as valid, means no padding is used. So stride is given in this way. Stride is equal to whatever specific stride size you want to specify, that you can give. So it is 1 by 1. And then specify what input shape we are giving. So particularly our input image is in dimension of 150 by 150. So I'll be providing that particular dimension only. So input shape is equal to 150 comma 150, and channels used in these images is 3 RGB image, because these are RGB images. Then what we have to do is put this comma, always put comma, so that we are going to stack upon different types of layers. So another layer that we'll be using now is layer, uh, layers dot batch normalization. This is just to avoid overfitting type of things. So it is used to avoid overfitting. After that, we'll be using layers dot activation, and then specify the activation function that you want to use. So we are using ReLU. As you have understood how ReLU looks like, it is maximum of 0, or the value that is given over there. So maximum of 0 or X, whatever it is. So this is the activation function that we'll be using, rectified linear unit. So next unit that we are going to use is the ReLU is not default. We are specifying it. Okay. Layers dot max pool 2D. You have studied max pool 2D also in detail. That it is just the subsampling. So we'll be using 2 by 2. So it would be in 2 by 2 filter size, it's going to take the maximum value. So let's give stride as 2 by 2. Okay, so let us now first of all see the summary. So for that, mm, okay, I forgot to use comma over here. It's always right. Then we'll be seeing model dot summary. So here we are. We have used a convolution layer. No need to normalize image at the beginning. We'll be normalizing it. Okay, when we are going to read the complete data set using data generator, at that time we are going to normalize it. Okay, right now we are only building the model. After that, I'll show that we are going to normalize the image. Okay. Okay, so we have built a model with one convolution and we have used activation as rel. So in this similar way, we can add upon layers to it. Let's again add one more layer of convolution. Let's copy paste it. Then here, let's do some changes like we can use filter size as 32. Okay, so padding equals to valid means no padding we are using. So zero padding would be used when we specify it as same. If you are giving it padding equals to same, then zero padding would be uh, specified over here. Okay. Okay, Tamanna, that was your answer. Then we move upon next thing we were doing. We were adding more layers. Convolution we have added. Then again, let's make one more convolution, and this time with we don't require these things now, input shape, because from above these dimension would be passed to the next layer. So we don't require input shape over here. Then we have 32. Let's change it to 16 filters. These are what changes I have made. Okay, all good till here. So with this, we have three convolutions. Okay, so we will analyze this parameters later on. Let's first of all build the model. Okay, so see, talking about the number of filters, it's up to you how you want to specify it. This depends on your the thing that you want to solve. Okay, so you can take the filters as you wish. So are you all able to do it? Should I wait or you are able to do? Should I move ahead? Yes, you can in future also, if you want to create more layers, you can add layers onto this model, and you can see the summary using model.summary. So till here we have three-dimensional data. See, we can see here it's of dimension 17 by 17 by 16. So what we need to do is we need to flatten it. You are till now very much aware of using layers.flatten for flattening it to one dimension. So what we are going to do is add this layer onto layers.flatten, and then flatten it, and then we will add dense layers. So layers dot dense with 32 units. Then again we will use suppose Let us use layers dot dense with 16 units, and then layers dot dense with 6. Let us add activation also, and we'll take same value, and here give comma. Okay, Shivani, batch normalization is only to reduce overfitting type of problems. It normalizes the batch, and it is usually like it is a good practice to use it after the convolution layer so that you get good results. That is the only thing that we use. Okay. So the last dense layer, you can see I have used specifically 6 neurons over here. The reason here is very much clear. Can anyone tell that why we are using 6 here? Uh, Anyone can tell in chat box that why I'm using 6 neurons? Yes, output we have 6 classes. That is the reason we are using 6 neurons. So here we have layers dot activation as softmax. So we are providing softmax activation here so that classification could be performed in different 6 classes. It's going to give you probability of these 6 classes. Ma'am has explained you that particular one image is having something 0.6 value, another one is having 0.4, another one is having like 0.6, one class is having, another one is having 0.1, then 0.2, like that. If these probability values are present, then the one which is having the maximum one, that particular class is going to be get predicted. For that, softmax is used. So at the last layer, we use softmax layer where we want to classify our objects. So it is overall requiring 1,73,958 total number of parameters over here. Okay, so this is what we are doing here. So you can see convolution, batch normalization, then activation is present, max pool, and these things are stacked upon each other. Using model.summary, you can print what model and the output shape. You can see what is over here. Like the initial 150 cross 150 initial input was given. So as we know that dimension is going to get reduced when convolution was applied. 148 by 148 by 64. Total number of filters that we were having was 64 that we have applied. See over here, we have used 64 filters. Then we had 32. So here you can see that output dimension is having 32 filters here in convolution, second convolution. Okay. How do we decide how many neurons should be used in each layer? See, in initial here, it is your like experience type of thing that how many neurons could work. That is the choice that you can make. It is up to you. And the another thing is that how you want to like extract features. Depending on that, you have to decide what neurons you have to use. But the last layer that you are going to get, when you are going to get the output, that is to be fixed. Like number of output classes that you are going to use, that should be the number of neurons at the output layer. Okay, above that, that is the customized thing, that model building, you have to do it by your hit and trial type of thing, that where you can get the better results. Okay, so should I wait, or you are able to do with me? Can you please reply that? Please wait. Okay. So people are doing. So let me wait for a minute or two so that you can do it. Then we will compile our model and then train it. Okay, Malika Shri, now should I proceed? Okay. Okay, now let us see what how can we visualize this particular model building. So for that we use Keras dot utils dot plot model, and then the name of model. We have initialized it using model. See over here, we have used model here, and this is the name of our model, and then we have written everything inside this. So here also we have provided model dot summary. So we'll be using this name. After that, we'll use where we want to save this picture. So we'll provide this, provide any path where you want to save this pic, and then run this cell. So the layers that you have added, you pictorially you can visualize these things like convolution. Then we have added batch normalization, activation, max pooling, then another convolution, max pool. Then we have flattened and added dense layers. So visually you can see all these things. Yes, Tamanna, we have added total number of 3 convolutions. Okay, we have added 3 convolutions. Okay, so all good till here. Now let us read the data, complete data set, and where we are going to do the rescaling thing, and then we are going to provide the augmentation also. So for that, we are going to import the image data generator that we would require to read all of the data from this folder. For that, from TensorFlow dot keras dot preprocessing dot image, we will be importing image data generator. Image, image, image data generator, and then we have train data gen, Inside that, we'll be reading the training images. Here, we will rescale to a value of 0 to 1. So we will divide it with 255, and then we will use zoom range for augmentation. Uh, 2 by 2 in max pool is that with 2 by 2 filters, we'll be using the max pooling. We have, like ma'am has shown you an example at the end, where among four values, you were selecting one of the value. That is what is specified in 2 by 2 brackets inside max pool layer. Okay, so in zoom range, uh, we'll be doing it using zoom 0.2 value that we are specifying. You can give any of the value. Here, these things are just the augmentation type of things. So any type of augmentation you can use. Like I'm using horizontal flip also. Horizontal flip. For flipping the image, you can use vertical flip as well. That is up to you. So I'll be using only two augmentation techniques here for my training images. Okay, so this is what is my train data gen. Another thing that we'll be using is the test data gen, uh, and it would be having the rescaled value only. So image data generator. Okay, and this would be having rescale as 1 divided by 255. Uh, then I'll be using train generator is equal to train data gen. Let us copy it, and then flow from directory. Flow from directory is used to read the particular directory path from which we are going to use these images. That is the pipeline of that uh, pipeline of these images would be provided during the training of the data set. During that time, the pipeline of this whole complete data set would be given as an input in form of batches. So for that, flow from directory is used. So here, we need to specify the path. Then for that, you will have to go to that particular path where your training data is present. So I have my train data over here. So I'll copy this path and provide this path over here. Okay. So this is the training path. Uh, what do we need to augment? We need to augment the training data so that we can get better accuracy. Like augment means like you would be having horizontal flip images or as well zoomed images also. We would be having more variety of images during our training process. So on the fly, when training is going on at that time, these more number of images could get into the training set, so that we can get variety of images and more better training can be performed. For that, augmentation is used. Okay, so with this, after that, we'll have to also specify the target size of the image that we are going to use. So our target size was what, 150 by 150. So 150 by 150 images we are using, and then we have batch size. So the images would be provided in form of batches of eight images. And class mode is categorical. Similarly, we'll be having the validation generator as well. So let us copy this. So here we will rename it as validation generator and specify this as test data gen dot flow from directory, and we will specify this path as validation, and target size would remain the same, path size also same, and class mode is categorical because we are having six different categories, so we are using class mode as categorical. If you would have used a binary like two class classification, then it can be binary. There are various types of class modes. You can visit this image data generator. You can search this and you can find it more like type of parameters over here to be provided. So with this, we have built the data set that we want to read. So here you can see that 578 images are provided to six classes, and we have found 71 images to the validations. Now, next step that we do is uh, compile the model. For that, what we require is the important things is the optimizer and loss function. So we'll be importing Adam optimizer. Uh, so from Keras dot optimizer import Adam, and then let us name it as op. Then we have Adam. The learning rate that we want to specify, any learning rate you can give, that is up to you. 0.01 I am giving. Then we'll be compiling it. So model dot compile. Here in optimizer, specify the optimizer that we want to use. So we have stored it in OPT, the Adam optimizer that we are using. Next is the loss function. Loss we'll be using is categorical. We are having six classes, so categorical. Cross entropy loss. Then the matrix that we want to see, on which we are going to check the performance of the model, that is specified using matrix is equal to, in square brackets, in uh, this quotes, right, accuracy. Then you can also specify AUC. Uh, you also have precision. So we can write all these things, whatever matrix that you want to see, that we can, these are already present in Keras library. So we can directly call these things. You can also build your own functions and then you can call. That is also possible. So compile. Okay, Keras optimizers. I think it's optimizers. So here we go. Yes. So it is compiled. Now the important thing that is to be done is the fitting of the model. That is the training thing. Let me close this thing. Okay, so now we will fit the model. For that, we will store it in a history variable, so that we can see the graph also. So for that, model dot fit is used. Model dot fit, and then inside that you have to provide the data generator that we have built. So we have built train data generator. We have the training images seven. How many? 578 training images we had. So we will provide this variable, then epoch that we want to train. Since we don't have much time, so only for 5 epochs we will run. Batch size is 8. Then we have validation data. Validation data is equal to validation generator. We had the name named as, here we had validation generator. So let's write this, and then validation batch size to be specified. Validation batch size as 8. I have not taken GPU. So first of all, see, you have to switch to GPU runtime. So for that, you have to change the runtime type. Go to this runtime, go to this runtime tab above, then change runtime type. Here you can take GPU, then you have to take any of the GPU. I'm taking as test T4 and then save it. Your notebook would again get connected to the uh, collab here, so that our processing could get faster. For that we have used GPU. Okay, so from where we need to, our splitting and unzipping thing was already done, so we can directly start running ourselves from over here. So let's run all the cells. Optimizer is, what does optimizer equals to opt means? Optimizer, here see, we have specified Adam optimizer. So that is only that we are giving here. You can write directly also, you can write over here Adam optimizer. Okay, Tamanna. We have to specify these optimizers so that training can be performed well. Uh, Sorry. So it is going, first epoch is going to take a bit time. After that, it's not going to take much of your time. You can increase the number of epochs if you want to increase, but here like I only want to give you a demo and it's quite going on for 2 minutes. So this epoch is going to take 2 minutes. So I've only specified 5 epochs. So you can train it for more number of epochs. After this, next epoch is not going to take much time. Till that time, this training is going on. Uh, let's plot the graph that we can see of this training thing. So for that, we'll be writing it as import mat. We have already imported matplotlib.pyplot. So we'll write it as print history, history dot ease. Then plt dot plot history. We will see the accuracy. Then let's copy this. So we have val accuracy. So we will provide title as model accuracy. Title as model accuracy. PLT dot y label that we will be giving is y label accuracy. and X label would be the epochs that we are training. So for 5 epochs we are training. So X label epochs, and in legend we will specify accuracy and validation accuracy. So PLT dot legend. Here we have ACC and validation accuracy. Where it's going to show is this is the position where it's going to print this statement. This is the upper left corner. Then let's print it plt dot show. So it would not right now display because our training process is going on. We can print it once this training process gets completed. So like this epoch is not taking much of the time. So we can see that yes, validation here accuracy is 22, here validation. This is like increasing. Okay, so you can train it for more epochs. It can get increased. Okay, so it is up to us. We can change this learning LR rate, or we can change the optimizer also. Okay, so lesser number of epochs we have trained right now. We can train it for more epochs, like 30 epochs. Okay, so let us move ahead and see what the testing thing can provide us. So for that, we have to write test generator as well. Test generator is equal to test data gen dot flow from directory test data gen dot flow from directory. And here we can specify the path that we have used here. Um, then we'll have to give the target size as 150, 150, patch size as 8. Okay, class mode categorical. Okay, so till here, are you able to do till here so that we can begin with like evaluation and prediction of the results? Are you able to get till here? Okay, so let us evaluate the performance. So for that, results is equal to, for that we'll have to do, what things we have to do is, we have to evaluate and predict the results. So model dot evaluate, uh, I have not given the test, spelling mistake. Increasing or decreasing number of epochs is like how much training you want to provide to your model. That is for how many number of epochs you want to train. That is what is meant by the number of epochs. Okay, how many times you want to reiterate it so that it can learn, so that the model can learn it better. Okay, for that it is used. So model dot evaluate, we have test generator, comma, batch size. Deciding number of epochs is like you have to train it and see that when your graph is about to saturate. That is what is said to be a good training process. So for that, you have to see that when your graph gets flattened. So that number of epochs you have to train your model. Okay. So with this, we can predict the values like x is equal to model dot predict. Then we will provide the test generator path, and then we will provide the batch size as one images we'll be seeing in this test folder. So with this, you can see different types of what probability values each of the image is having and which one to be selected, so that you can have a better like your which class it's going to get predicted. So you can see over here, like for the first image, just a minute. Uh, hmm. So like first image, it's having 0.22. Uh, go up. Yes. Here, which value is highest? So it's the class, like it's the class, last class, that is the fifth value. So what is the class indices? You can see different probability value, this total is going to be 1. So the class that is having the highest probability value, that is what is the output of the model, that is the prediction result. So it's going to predict that particular class which is having the highest class value. Okay, so your training pattern could be different from mine. You can tune your model yourself, like giving different learning rate, giving different optimizer, so that you can find how many like what difference it is making. So that is what you can hit and trial and see how better results you can get. So for this, getting the maximum value out of these six classes, you have to maximize, see the what the maximum value is. For that, we will use np.rmax. So y predict is equal to np.rmax, and input this this prediction what we have got, that we are going to give, that is the x value, that is the prediction result, and we will specify the rows upon which we want to get the final output result. So this is what is x is equals to -1 upon these rows, it's going to give the maximum result. So what by predict it has not learned much, so it would be misclassifying the classes. So it is already predicting, like wrongly giving the things. So otherwise, it could give you the right results. So let me now cover some important things uh, here. Just a minute. Let me cover these things. Uh, okay, so let me show you some important results over here in this file, where this training process was better than this particular file. Here, I will provide you this thing. So this type of training pattern was there. Then we have done all these things that we had, printed the results. So what we were getting is that we were having some of the values as misclassified as 0 and 1, but most of them are rightly classified, and we were getting 67% of accuracy. Here, sorry, 71% of accuracy. So it's quite a good, like for 20 epochs, it's quite good training thing. The important thing that in this tutorial that I want to show you is uh, the activation maps that we have seen in the theory, how this activation map can be seen. So for that, you have to install Carrot, pip install Carrot, and then you have to import Carrot and then expand its dimensions. So that why this particular line is used, so that it has one batch size. See, you can see over here one batch size, input size is 150 by 150 by 3. So for that thing, this np dot expand dims is required, because this thing is required inside this Carrot library. So for calling that, we require character.activation. And here we are providing our model, particular model and the image on which activation of each of the layers we want to take. So I am taking this particular sample image as my input image. So what we are trying to visualize is the activations that what things these layers are learning, that we are going to see. So here we have displayed these activations using character display activations, and inside that we have provided activations. Okay, fine. So let us see what it has learned through this thing. Let us see. It is going deeper into the network. It is going like it is showing these are the number of filters. These small images that you can see, these are the number of filters. We have used 64 filters here. So 64 different types of features are used. You have seen that how they were stacked upon each other, like consecutively they were put uh, one after the other. So here you can clearly see that yes, this posture is how much nicely learned here. See these things. So this is what inside that thing that even ma'am has explained you clearly, that how features are learned. One of the slide has shown you that someone has done on ocular disease. So this is how these activation functions you can use in your problem also. So this is like you can see these features are clearly visible, that this posture was in center. So it is highlighted over here. Okay, so this was the important thing that I wanted to cover. With like we are left with 10 minutes, so let us also cover some more important facts that we have not I have not used during this writing of this code. Let us see how this callbacks can be used. Important thing is the callback. You can while you are training, sometimes there are sometimes you get disconnected from Google Collaboratory, or you want to save the path, save the weights in between. So rather than saving the weights, at the end, you can use checkpoint file checkpoint callbacks. For that, you have to specify the path where you want to save these weights. The thing that you are learning, that is the weights. So you want to save these weights every time. So for that, you have to specify the path, then specify this model checkpoint over here, and then specify the path, and then save weights for what? When you have the validation accuracy as maximum for that particular thing, you have to save the weights. Only those weights are to be saved. So best weights would be saved, and that you can call in your model.fit thing. So this is very important thing, model checkpoint callback. You can learn about this more into detail, from here. Model callbacks, checkpoint callbacks, keras. So this is the callbacks API. You can go over here, then see that uh, here model checkpoint is present. So this is model checkpoint. This is the model checkpoint that we have used. Okay, so you can study this also, and you can use it in your file as well. What can we infer? We want to infer the learning things that is done in the inside the model that we have built. For that visualization, only activation maps are seen, that what these filters are learning. So okay, Tamanna, that is what for visualizing we have seen activation map, how good it is, and how bad it is. Okay, so let's go to our file over here. And another thing is that, seen, we have trained our model. Then one thing is that you can use callbacks if you are not using, as in our earlier um, previous file, we have not used callbacks here. See, you can see I have not used any callbacks. So what I need to do is I have to save my model. So for that, you can use this thing, model dot save, and provide the path of path of the file. So here you can specify any of the path and save that model, so that you in future, whenever you require the weights, at that time you don't have to train it all over again. So for that it is required. So let me copy this path and paste this path and give the name as weights.h5. This is the extension, so that you can save complete model, or you can only save weights also using model save weights, using model.save weights, so that weights would only be used. And then whenever you again you want to use this model or these weights, you need not to train it all over again. You can only load the weights, model.load weights, and then provide the path of this particular folder, so that you can again test the results. Okay, so this was the thing I wanted to tell. Then one more thing that you might require is the calculation of flop counts. Uh, so here, uh, the number of how much complex your model is. Sometimes that thing is also to be taken care of. So you can see how your model is performing using Caris flops. So here, pip install Caris flops from Caris flops import get flops, and then flops is equal to get flops model, comma, specify the batch size as 1. So it will install it first and then print how many. So print. So okay, so I'll provide you everything with this. If you have any doubt, you can ask it. Otherwise, we are done with this session. So you can ask me if you want to ask something. Uh, Otherwise, I'm done with my like I will provide you my this Python file with all activation and everything, callbacks and everything would be present over there. What does load weight? Load weight is used to first of all we save the weights that whatever training we have done, that we are going to save it, and then after that we will load the weights. Whatever things we have learned, first of all we have saved, and each time you cannot train the model because it takes time, like you have taken 10 minutes also. So you do not need to again retrain it. You can directly load the weights from the path where you have saved it, and then again test the results. That is what we need to. Okay, I'll Komal, I'll provide you my email address. Okay, if you have any other doubt, you can ask me. Uh, any doubt or something, or we are done with this?